Hey guys, so we're on the fourth and final conic section, which is circles. All right, and we saved the best for last. We love circles, and it is probably the easiest one, which is why we saved it for last. All right, so it's also saved for last because you guys have done circles in the past, so I know this shouldn't be new for you. All right, so a circle is the set of points that are equidistant, equidistant from a fixed center point. Okay, so what does that mean? It means every point on the circle is the same exact distance from the center point. And the distance from any point on the circle to that center point is called the radius. Hopefully, some of you were yelling that at your computer because you knew that already. Okay, so all the points are equidistant, the same distance from the center point, and that distance from each point to the center is called the radius. Okay, next, a diameter is double the radius. So your radius times 2, and is a segment connecting 2 points on the circle and going through the center point. Okay, so a diameter doesn't just connect any 2 points on the circle, it has to connect 2 points and go through the center point. All right, and it'll always be double the radius in length. All right, and finally, guys, a circle is actually just a specific type of ellipse where the major axis and the minor axis are the same length. Okay, so if you think back to ellipses, you had your major axis and your minor axis, and one was always longer than the other. It was either a horizontal ellipse, because your major axis was horizontal, your minor was vertical, or vice versa, and it was a vertical ellipse, meaning the ellipse was taller than it is long, or the major axis was vertical. Now, the major and minor axis are the same length, so you can't really call one the major axis or one the minor axis. And it's not vertical or horizontal because it's equal in both of those directions. All right, so now the equation of a circle, and this should not be new to you because you learned this, I think, in Algebra 1 and Geometry and Algebra 2. You have x minus h squared plus y minus k squared equals r squared. Okay, so notice this is our first conic section that's not equal to 1. It's equal to r squared. Okay, but something in common with all the other conics, or at least ellipses and hyperbolas, h comma k is your center point. Okay, and of course r is your radius. Okay, so notice in the equation, it's r squared. Okay, so you'll have to square root that number to get the radius when you're given an equation. All right, or going the other way, if you know the radius and you had to come up with the equation, you have to square it. All right, so now let's look at an example. All right, so this equation here should look like a conic section that we've dealt with. It should look like, I just made one around the equation. It should look like an ellipse, right? That's the ellipse equation, not a circle equation. Okay, so this here is in ellipse form, meaning we need to make it standard form for a circle. Okay, so once you realize that both denominators are the same number, they're both 16 in this case, that tells you that it must be a circle. Okay, so same denominator. Okay, so ellipse with equal denominators means it is a circle. Okay, and very easy to get this from ellipse form to circle form. Okay, the standard form for a circle is multiply everything by 16. Okay, and golden rule of algebra, whatever you do on one side, you must do on the other. Multiplying the left side by 16 just gets rid of your denominators. So you have x minus 3 squared plus y minus 1 squared. And now on the other side, you had 1 now times 16. And now this is in standard form for a circle. Okay, and you can figure out the center point and the radius from that equation. Your center point, h comma k, well, x minus h, so it's 3, y minus k, so that's 1. And now remember, most common mistakes on this is to say r equals 16. Remember that that number on the other side is r squared. So square rooting 16, the radius is actually 4. All right, and now a little refresher on graphing a circle. Start with your center point. So I go 1, 2, 3, 1. My center was at 3, 1. Now the radius is 4, so you're going to go up 4, down 4, left 4, and right 4. Okay, so you just really need those 4 points. Now you can draw your circle. All right, you can use it with the drawing tool on Kami. I'm going to use the shapes and go to the circle. So if you guys want to take a look at this, start at one of those 4 endpoints. All right, and then go out to one of the other ones. All right, and now if you click select over on the top left there on Kami, all right, you can take the other endpoints and drag them over. All right, and now I've got my circle. All right, guys, so tomorrow in class, we're going to get more into examples of graphing circles. We'll do completing the square with circles, but we're going to take the least time on these because you guys are already familiar with them. And really, they're just a special type of ellipse where there's not a major and a minor axis because both of those axes are the same length. All right, guys, I'll see you tomorrow.